maximum and minimum of functions of two variables. First, you take the steps how we are going to solve this type of a problem. Sir, what is the procedure for this one? The working rule is first you are going to differentiate the given differential equation, sorry, given equation with respect to x and with respect to y. Later you are going to equate its equals equal to 0. Find your dou f by dou x and dou f by dou y and and equate to 0 and solve these equations for x and y. That means you're going to differentiate your x equation you're going to differentiate your given equation with respect to x and with respect to y. Then you're going to equate dou f by dou x value is equals to 0 and dou f by dou y is equals to 0. Then that equation you're going to solve it for the value of x and y. That value of x and y are known as your stationary values. You're going to get the values into the pairs. Let's say it is in the form of a1 comma b1, a2 comma b2, so on. Be the pairs of values, we can say as in a stationary values also. After that your second step will be you're going to find lmn, find l, which is equals
Ma'am,
to,
I didn't
yes,
understand the, the like the solve the equation for x and y
first equation. See,
equated to zero.
whatever the equation is given to you, that f of x, the given equation, suppose your equation it's given as in a some polynomial equation. F of x is equals to 3x square plus y square plus some constant they have given. You are going to equate the given equation with respect to x and with respect to y. When you're going to do the partially differentiating with respect to x to this equation, what you're going to get, your dou f by dou x it's equals to 6x you're going to get. Then your dou f by dou y it's equals to 2y. Then later what you're going to do, you're going to substitute your dou f by dou x is equals to 0 and dou f by dou y is equals to 0. When you're going to substitute here is equals to 0, according to this equation it will become as a 0. That's not possible. For just for explanation I have taken this one. When you're going to equate these two equations occur, you're going to form it into the equation form. When you're going to solve this equation, you're going to get some values for x and some values for y. That values will be known as a pair of a values or a stationary values. After
Ma'am, I
that,
didn't get that part. Solve the equation. Oh, ma'am, if it's a quadratic equation.
not quadratic equation ma, whatever
Ma'am,
the
we got
equation.
6x and 2y.
See,
So how
first,
would we?
listen. First, you're going to differentiate your given equation with respect to x. Whatever the equation it's going to be, what you're going to get in the form of dou f by dou x, it's equals to, right? Then after that, the same equation you're going to do partially differentiating with respect to y. That you're going to get dou f by dou y is equals to some equation. Then what you're going to do according to the theory, what it's saying that whatever the equation you got for the partially differentiating with respect to x, equate that equals to 0. That means you're going to substitute your dou f by dou x value is equals to 0 and dou f by dou y value is equals to 0. Then you're going to form it into the equation form. That suppose consider as an 3, consider as an 3 array 3x square plus 4y square, which is equals to your dou f by dou x. Then you're going to substitute this value is equals to 0. That will implies 3x square plus 4y square, it's equals to 0. Then suppose if you're getting a dou f by dou y value is equals to 3y square minus 3ax. Then you're going to substitute this value is equals to 0. That implies 3y square minus 3ax is equals to 0. You're going to make this equals to equation number 1 and this is equals to 2. You're going to solve these two equations for the values of x and y. Whatever the values you're going to get, that will be known as your, that will be in the pair of in this form. Now it's a clear, Aditya.
Yes, ma'am. Yes, ma'am.
Now it's a clear for you.
So
What does
pair of
means?
values is just the.
When you'll do the problem, it will be more clear for you. Don't worry.
Okay. Okay, ma'am.
Right? It will be clear for you what is going on. Then after that, what you're going to do, you're going to find your L value is equals to dou square f by dou x square, and m is equals to dou square f by dou x into dou y, and n is equals to dou square f by dou y square. You're going to find the values of L, M, N, where L is equals to your dou square f by dou x square, and m is equals to dou square f by dou x into dou y, n is equals to dou square f by dou y square. After that, your next step, your third step will be you're going to find ln minus m square. If this value is greater than 0 and your L is less than 0 at your stationary values, that is a1 comma b1, then then it is a point, it is a point of maximum, point of maximum. You are having now cases. If you are getting your ln minus m square is greater than 0 and your L is less than 0, then that point is known as ye maximum maximum mag, maximum and your f of a1 comma b1 is maximum value, is maximum value. Then the next second case, in this second case will be if you are getting your ln minus m square is greater than 0 and your L is also greater than 0 at a point a1 comma b1, then it is a point of minimum, point of minimum, and your f of a1 comma b1 is minimum value, is minimum value. If your next case, third case, if you are getting your ln minus m square less than 0 at a point a1 comma b1, then it cannot it cannot be declared as a minimum nor as a maximum. If your ln minus m square is less than 0, is not an extreme value, not an extreme value, that means it cannot decide whether it has to move to the maximum side or a minimum side. Neither a maximum nor a minimum at a1 comma b1. Next your fourth one, if ln minus m square is equals to 0 at a1 comma b1, there will be no conclusion. You're not going to have any conclusion for that one. There will be no conclusion for that one. It's a clear what you have to do here. For maximum and a minimum, only three steps are there. First, you're going to find the partially differentiating with respect to x and with respect to y. Then later what you're going to do, you're going to substitute your dou f and dou f by dou x, dou f by dou y values is equals to 0. Then that will change it into the form of equation form. You're going to solve the two equations for the values of x and y. That x and values will be in the pair form, that is in the form of a1 comma b1 or x1 comma x2, x1 comma y1, x2 comma y2, so on. Then after that, your second step is what you're going to find L, M, N values, where your L is equals to dou square f by dou x square, M is equals to dou square f by dou x into dou y, N is equals to dou square f by dou y square. After that, third step is for investigation. What you have did the two steps that you have to investigate with the from the first step. You got that values, whatever the values you're going to get, those many cases you have to discuss over here. The first one is saying if ln minus m square it's getting as a greater than 0, along with that l is less than 0, then that point will be declared as it's a maximum, and the function is also going to be known as a maximum function. If ln minus m square it's greater than 0, where l is also greater than 0, then that point consists as a minimum, and the function is also going to have a minimum value. If ln minus m square is less than 0, then it cannot decide either it going to be maximum or a minimum. And ln minus m square it's coming as an equals to 0, there will be no conclusion. There is a no solution for this one. Aditya, now it's clear all the points.